Hi students, welcome to our class, and today I want us to look at the last thing on cubes and cube roots, and it is the remaining part of what we did not do on our previous video. And our today's discussion will be on cube roots of numbers using mathematical tables, and we are going to give some examples of the numbers that we are going to find their cube roots using mathematical table. And the first number will be 0.0218. Second number will be 8,752, and our last number will be 2.383. These numbers will serve as examples of the so many numbers that we can find their cube roots using mathematical tables. And we are going to see on the way we can find their cube roots using the table of cubes in our mathematical tables. The procedure on how to go about it is that one, we are supposed to write the numbers provided as r times 10 raised to power n, and we are going to find that r must be a number between 1.0 and 999.9, and n is an integer, a multiple of 3, or a number divisible by 3. N therefore could be the following numbers: -6, -3, 0, 3, 6, 9. We are then supposed to find the cube root of r in the mathematical table, and then find the cube root of 10 raised to power n. And this is how we are supposed to work it out. 10 raised to power n divided by power 3. In this case, we are not going to use mathematical tables. So if you find that n, divide that n by 3, and by doing so, you'll be getting the cube root of that part of 10 raised to power n. And in this case, we'll have solved that part without use of mathematical table. But for the other part of r, it is the one that we have to use our mathematical tables to get is cube root, and therefore we have to ensure that our r must be a number between 1.0 and 999.9. For our procedure above to be satisfied, then we are supposed to write these numbers as 0.0218 should be written as 21.8 times 10 raised to power -3. So we have to ensure that that power must be a number divisible by what? 3. And we make sure for the other number given, it falls between 1.0 and 999.9, and making sure that the power of 10 is 3, or a number that is divisible by 3. So 8,752 is equivalent as saying 8.752 times 10 raised to power 3. 2.383 remains as 2.383 times 10 raised to power 0, because 2.383 lies between 1.0 and 999.9. So the other step is to make sure that part of 10 raised to power n, we have simplified it by getting the cube root. And how to get the cube root is that we divide the power by 3. So every power of the numbers that we have written them such that they fall between 1.0 and 999.9, we divide by 3 that power. And to continue with that, we will make sure that already we have simplified that part of 10 raised to power n, where n must be a number or an integer which is divisible by what? 3. So this part shows us that already we have simplified that part of 10 raised to power n. The remaining part is the part of r that we are required then to find the cube root of these numbers in our mathematical tables. And we are going to find like 21.8. We find the cube root of that, which can also be said it is 21.8 raised to power a third. 8.752 cube root of that. Some people, or you can also say that it is 8.752 raised to power a third. Power a third and cube root is the same thing. So we normally say that nth root of a number is it's a power which is a fraction power, 1 over n. So let us use our mathematical tables and let us follow and see how we are supposed to find the cube root of these numbers. And our numbers are the r part that we did find then. So our first number is 21.8, and we look at within now our numbers that are in the the part of cubes table. We have a number out of the so many numbers in that table where we have 21.8, or a number closer to that, 21.8. And then our number which is closer to 21.8 is 21.718. So first of all, we look on the left, and along the x column we will have 2.7. So we write that as part of the solution, 2.7. Then we look at a number on top of our table along the x row, and that is also part of our solution, and it's a digit that counts after 7, and we write it there. It's our 9. It's all those numbers that I've circled, the 2.7 and the 9. We write them as part of our solutions. But this does not satisfy the solution, because the 21.8, we did not find it in our mathematical table. So among the so many numbers or solutions that we have, that number that was closer to 21.8 was 21.718. So this was a number closer to 21.8. Therefore, we need to check on how to go about it. And on how to go about it, we are supposed to get the difference between the two numbers, 21.8 and 21.718. So if we get the difference by use of our calculators or by use of any other method that we can use to find the difference means we subtract between the one which is bigger and the one which is smaller. If we get the difference, it will give us 0.082. So we want to find on the other table, where do we have 82? Among the so many numbers we have in that table, we have a number which is slightly above 82, and that is the number that we require. We may not find 82, but we need a number which is slightly above that number. Actually, the next number after 82, it is what? 90. So we cannot take a number which is lower than 82. So I've circled 90. So on top of the table, a number which coincides with 90 on the x row, it is which number? That is what we want, and that number is 4. It is that number that we needed to know, actually, so that we have our solution satisfied, so that we write that number now after 9. 2.7 is along the x column. Where is our 9? On the x row. Where is our 4? Still on the x row, but on the other table. And we need to understand that 34 is very important, because the solution is almost the same as 21.8. If you cube 2.794, the answer that you should be getting, it should be 21.8, or a number that is almost that number. Then we have the second number, which we are supposed to find its cube root, and that number is 8.752. We check on the numbers that we have in our table. Where do we have 8.752? We cannot find it in the table among the so many numbers that we have, but there is a number which is closer to 8.752. We find it there. It is 8.742. Then we look on the left of that number. Along the x column, we have 2.0. So 2.0 becomes part of our solution. That notwithstanding, we need to look at a number which is on top of the table and coincides with our 8.742. Which is that number on the x row? It is number 6, or digit 6. That digit 6 comes after 0, and it is still part of our solution. But still, this does not satisfy our solution. The cube root of 8.752 is not 2.06. We still need to say the remaining part that we did not get it in our table. We did not get 8.752. What did we get? We got 8.742. So we need to get the difference. So we take 8.752 minus 8.742. If we get that difference using our calculators, we will be able to find the third decimal digit of which it is part of the solution. So we take our calculators and we get the difference. So what is the difference between 8.752 and 8.742? If we do that, I'm very sure we will be getting 0.010, and that 10, which is the last part of the answer that we have gotten as 0.010, is what we need to find on the next table. We have so many numbers on the add table, so we find a number which is more than 10, but it should be closer to 10. Okay, it should be above 10 or exactly 10, but it should not be lower than 10. So which is that number? It is number 13. So we cannot go for any other number other than 13. We cannot go for a lower number if there was other than 13, because we need 10, or we need a number which is slightly above 10, so that our solution will be satisfied. After getting that 13, we look at a number on the x row, still in the same table, that coincides with our 13. Above 13 on the x row, we have digit 1. So that digit 1 is now part of our solution, and we write it after digit 6, and we have 2.061. So the cube root of 8.752 is 2.061. We have our last number, which is 2.383, and this number, we look in our first table. Where do we have 2.83? 2.383, we find it in the table. We have it somewhere, not exactly, but a number that is closer to 2.383. So first we look at that value along the x column that coincides with the 2.353. So after looking at that, we will find that we have 1.3. 1.3 is what we need as one of the part of our solutions, and we still need other digits for us to satisfy the solution. So we look at a digit along the x row that is above 2.353, and we find that that digit is digit 3. So that digit 3 is still part of the solution. So we write it after the 3 that was in the first decimal place. But are we satisfied, or is our solution satisfied? No, it is not satisfied. Why? We did not get exactly 2.383 in our tables. So there is a difference, and that difference is the one that we need to get first and see where can we get it in the next table, that is the add table. So we get the difference between 2.383, and if we get the difference between 2.383 and 2.353, you'll find that we have 0.030. That is what we have. So you get the difference between the highest or the bigger number and the smaller number. So the smaller number, it is that number that we got, number nearing 2.383. So we get that it is 30. So 0.030, the 30, that last part is what we need, the 30. So we look at a number which is 30, but should not be lower than 30. Either that supersedes 30, and what is that number? That number is 33, because we do not have 30. So we go with the number 33. So that number is there in our next table, the add table. Now it will help us to get the other digit that we need, and which is part of our solution. And which is that number? It is number 6. On the X row, on the last table, that is the add table, we have digit 6. So digit 6, we write it after the other 3 that we had, and now we will have 1.336. So you have to look at that, and you find the solution, and it is procedural on how to get it. If you cannot get the exact value in the mathematical table, so how are you supposed to do it? You have to find a number which is closer to that number that you intend to find its cube root. And already I've done some demonstration. I've used the mathematical table itself. I've demonstrated using circles. I've also demonstrated using rectangular boxes, and by doing so, I hope you have understood. So the part of solutions of those numbers will be given by the part of r multiplied by the part of the 10 raised to power n. After getting the cube root, what did we get? Like we got 2.794 in our first value as the cube root of 21.8. Then we got 10 raised to power negative 1 as the cube root of what? 10 raised to power negative 3. then we find the answer, which is 0.2794. We repeat the same procedure for the next number, and what did we get? That is what we're supposed to get, the cube root of what number we got in the mathematical table and the cube root that we got after solving the cube root of 10 raised to power n, and then we multiply the two and we get the answer. So in conclusion, I want to say that it's a must that the number that we have to get its cube root must be between 1.0 and 999.9. We must use tables. We must divide powers. And how do we divide powers? By ensuring that the n is a number divisible by 3, or a divisor of 3. Thank you.